Hello, everybody. Welcome back to our YouTube channel, all the things about Kotlin. I'm Anton, and today with me, I have two Vaadin experts, Martin and Mati. Hello, folks.
Hello.
Hey, hello. How are you?
So we have a session about building web applications with Vaadin and Kotlin. Uh, we have people coming on the stream, and I hope they will ask a lot of questions, and we will learn some things about Vaadin from Mati first. And I know that Mati haven't used Kotlin that much, so and
Not
that
that
will be
much, yes. Yes.
experiment. So we're gonna ask some tricky questions, and that will be fun. And after that, because Martin developed a very nice DSL for Vaadin with Kotlin, we will bring Martin in to the stream, and he will show us all the little tricks of that DSL. And basically, folks like who are on the stream watching us right now, let us know. Have you used Vaadin before? Have you tried using Vaadin with Kotlin, and how do you like it? With that, I'm going to pass the talk to Mati, and we're gonna invite Martin a little bit later to the stream. So everybody ask a lot of questions. We are happy to answer. And Mati, the floor is yours.
Thank you, Anton. Very nice to be talking for the Kotlin audience. I guess there will be quite a lot of, for example, Android developers in the stream who might want to do some web applications. And for them, I would expect that Vaadin is kind of a new thing and very handy thing that where they can utilize their existing skills. Yeah. What Vaadin is? Vaadin is, first of all, it's a company. We have been doing web application development tooling for 2 decades already, more than 2 decades actually. And Vaadin is also the name of the platform, and it actually kind of used to be name of the framework, but there is a ton of things in our offering these days. Today we are discussing mostly about the kind of the original Vaadin thing, the Vaadin Java framework, or in this case, we will replace this Java side here with Kotlin, of course. So because it's a JVM framework, you can use that directly in your Kotlin code. And yeah, Vaadin provides you a way to use like 100% Java or 100% Kotlin in your web application. And I would actually claim that the language is not important, whether it was Java or Kotlin. It's the thing that it's 100% of one language. So you can focus with one language to do your whole web application. And before Anton mentions me that it's you can also compile Kotlin into JavaScript. This is quite different thing. So yeah, in the past you were able to use Google Web Toolkit to compile Java to JavaScript, but Vaadin is not compiled or it's compiled into bytecode, but it's not transpiled into any JavaScript execution for the browser. So it actually executes in the JVM. And the framework part, that's actually quite small with Vaadin, or especially if all goes well, because components will be the thing that you will be using. So Vaadin comes with a ton of components ready for some business applications. So let's check out, for example, the grid. So this is one component that I will be using in my example as well. It provides a lazy loading mechanism where you can put basically any data for the grid and it doesn't choke your browser. So Vaadin components are smart and they are ready for your business applications. But hey, let's start with an example because I assume that every attendee here is some kind of a developer. So let's create a new project. There is actually a pretty nice starter application, like a project generator for Vaadin as well. So if you go to start.vaadin.com, you will find pretty similar to Spring Initializer, but that doesn't actually support Kotlin. So that's why I'm now using Spring Initializer in this example. And then I will give my project some kind of a name, Kotlin webinar, for example. And then we need some dependencies. So we need Vaadin and most often in my Vaadin projects, I also use Spring Boot DevTools. So this provides handy helpers for Spring Boot applications, so that it reloads faster. Basically, you get to see the UI changes that you're doing. And by the way, Vaadin is not tied to Spring Boot or Spring, so you can use basically any Java web framework or like below your Vaadin UI. And later on in the example, I will also use database and JPA just as an example that how you can connect to your backend. And I always use the latest versions, so I will take Java 21 and generate project that now needs to be imported into the IntelliJ. I was tempted to use NetBeans here because I remember that once in the past we were with Anton in one together in one NetBeans. I think it was in Java 1. We had a joint session in in there about NetBeans, and but yeah, maybe it's better to use IntelliJ in this session. I'm also gonna use the latest version of Kotlin. I have been using Kotlin for now a couple of weeks. I have been trying to use it in different kind of examples that I have been using, and I have noticed that this Kotlin 2 version is actually much faster than the stable one. So I'm going to use this here, but I guess that doesn't affect my Kotlin usage that much. The language is pretty much the same.
The cool part of the upcoming 2.0 release is that there are no new language features. It's basically a smooth transition to the new major version. It just stabilizes and improves the compilation speed.
Yeah, and you can really easily see that when you have this live reload that you will soon see that there when you make Vaadin UI changes with the 2.0 version, it comes almost immediately to the screen, unlike with the older version.
Nice.
All right.
So tell me, we are starting the Spring Boot application, right? And it's empty. It doesn't have any UI yet.
It doesn't have any UI. So if we go to localhost 8080 now and hit the screen, I will actually get something, because now Vaadin is actually, it by default runs in so-called development mode. So you got some kind of like helpers here. For example, this example code snippet will not be there if you compile Vaadin into the production mode. But this is very handy way to get started. You get this hint here, and then you have this tiny developer tooling here. So here you have, for example, editor for theme, and you can find some code from the view. You cannot, of course, now because you don't have any code yet. And you can configure certain feature flags for new upcoming features and so on. So this is now in development. Let's actually copy paste this code. This should go pretty well into the project.
So just to clarify, these features that you just showed, that the snippet of code, some extra UI widgets, they were enabled by this dependency that we added via the wizard, right? So there is a starter dependency.
It actually comes from Vaadin dependency itself. So in the build file, this is Gradle build, but here is probably some kind of a profile for the like a production build, and then this Vaadin helper dependency will be removed. But the DevTools dependency that I added there, that was from Spring Boot. So Spring Boot has this thing that basically now when I make a code change, let's actually first convert this into Kotlin file, because this is a Kotlin webinar. So now we have our first Vaadin U in Kotlin, and let's save. And now if I go here and wait a second, now it automatically reloaded. I didn't need to go to this toolbar here and click reload, but I can immediately see the changes on the browser. Typically, if I'm not in a webinar, I will use my secondary screen for the actual UI that I'm developing. Then I have my IDE open, and I don't need to change between the IDE and the actual UI. But in the webinar, it's actually much handier to have the webinar application running in the second screen. But
Nice.
that's basically the typical setup. When Vaadin application starts, you actually get an empty page. So there is some JavaScript and CSS. This is basically kind of a thin client that comes by the Vaadin framework, and there is an empty page. And then this thin client connects to the server, which is in this case the Spring Boot application. And the server, Vaadin framework on the server side, finds what is mapped to this URL. So this root annotation is kind of the declarative hint for the framework that this component should be mapped to the root context. We can change that into Kotlin. And now the UI should be mapped to a different address. Okay, we get this empty screen again, but it says that we have one root now. And if we navigate there, we can see that it's now mapped to Kotlin. So this is basically all that you need to know about the framework part in this part. There is more for it, but after that, it's basically just utilizing the components. So the vertical layout is one of the most simplest components there is, which basically just it's empty by default, but you add other components. This H1 element is just H1 element if you have been using HTML before. If you have not, that's basically the title tag. What's like when Vaadin actually comes into real use is when you have like dynamic UIs. So it's not the tool that you want to use for your web page, for example. If you have a blog that you want to implement, then from Spring Stack you could use, for example, Timeleaf and Spring MVC to render that. Much better tool for that. But when you have some interaction, and if you have only Java or Kotlin skills, then Vaadin is the thing. So let's create something more dynamic. So let's create text field. So simple component to input some text. Let's call it name and assign this into a variable. And then let's create also a button. And let's make a very provocative click me button here. And then we need a click listener that we're going to use as a lambda expression here. And now, because this is on the JVM, we can directly access these other fields. So in the click listener, we can directly get the current value from the text field. So if we have text field, we'll get value. And this is going to be name. And this is the name that the user actually inputted to the thing. And then we can use that, for example, add a new component to this same vertical layout. Again, let's add a paragraph this time. And put the name in there. Or we could use cool Kotlin features that I have learned. Hello there. Like that.
I have to jump in and correct you on the semicolon.
Oh, that happens all the time. But it works with it as well.
When you're coming from Java to Kotlin, you start typing semicolons in Kotlin, and then you spend some time there. You learn that you don't need to type them. You come back to Java, and then you miss them all the time because you don't have to type them at Kotlin. Now you just in the middle of those two, and you have to pick the side.
Yeah. What you see now is an empty screen, and there is a bug in my code. This is actually going to be easier in the DSL that Martin will show, but this is now object-oriented programming, so we need to add these two objects, the text field and the button as well. Let's put button there. And no semicolon. And hit save. And now we should have those components on the screen. So now if we type in something here as a name and hit click me, it doesn't reload the page. So now Vaadin framework just basically sends the change details. So it sends that the name, the content of the value, the name field is now this random string that I typed in, and this button was clicked. And then the click listener is executed. So if we repeat clicking it, we will get new paragraphs to the thing. And this is what makes vanilla applications very efficient, even if they were huge business applications with ton of components. So Vaadin applications, they consume quite a lot of JavaScript and HTML. There's a ton of things that it loads in the beginning. But then when you have it up and running, the communication between the client and a server is very efficient. And especially if you have some dynamic data on the server side, for example, if you have some new data coming to the server, then the development model really shines because you can make this connection between the client and a server. You can make it WebSocket communication with just one annotation. So if you add this annotation to your application, now it will use WebSocket. And if you would be getting some something from some background thread and you would be updating this object, it would automatically reflect on the client side. So it's very, very easy to implement, like push connection. But it's I call it push because it's really you don't need to do any server pushing, but it just happens magically. Nothing for you to take care of.
Can you show us how this magic?
Yeah, sure. Actually, this is not trained. How do you create a thread in Kotlin?
Thread is the function that basically stands for, that's the usual Java thread.
Yeah, so let's actually, one thing that you need to take care is that you need to have a reference to the UI object, because you probably want to synchronize the changes that you are having now if you have like a lot of data coming from different places. So you need to access all your UI calls there. So there is a helper. Access. So this takes care of all the synchronization between the. So now if there is multiple threads accessing this specific UI instance, then everything should be okay. So now let's add a new text and call it from thread. And then let's actually add a small post there. So how do you make a thread sleep?
Just sleep, yeah.
All right.
There was a question in the chat about the push annotation. So is it like setting up a new stream?
Well, it basically opens. Every user will get a different WebSocket endpoint, and their changes are only like streamed to those changes, and it depends about the server implementation. If you have like a lot of threads there, but with modern web servers like latest Tomcats, there shouldn't be any issues there. All right, and then we need to start it, I guess. Start.
Yes.
And shell configuration. That should do it. So now this app shell configuration that you implement here tells Vaadin to use push communication. And now if we get an illegal thread state, what?
Okay.
Well, it works in my Java code. I have no idea what's happening here, but maybe we don't want to debug this.
Yeah. Let's skip it for now.
Maybe I'm pretty sure it works later with Kotlin. Yeah. Instead, I will show another demo that kind of helps. Let's try to actually make it compile now somehow. Let's remove this part here. And yeah, you shouldn't be using threads. You should be using some kind of a executor service or something to postpone your stuff.
Yeah.
Let's try it out if it's loading. Yes, so now we have the old application here. But let's now integrate into our imaginary backend that I developed beforehand. So I have 2 Kotlin classes. This is actually the JPA entity and Spring Data repository. So this is basically one table from like accessed via JPA, and then we have the Spring Data repository. So this provides us a lot of like handy pre-made methods so that we can access all the rows from our database table. And then we need some test data as well. So let's add this SQL file to the project and override the app settings. So now we should also see the SQL queries that the server is doing. And now we have a backend. And because this main view that we created, this root annotation actually makes it also a Spring Managed bean, we can simply auto-wire that service here. Or in a real life, you probably have a service class there as well, but I'm going to do a dirty hack here and inject the repository here directly. So that's going to be there. And now we can directly go to this backend service that we have. So this is something that you cannot do if you are using something like on the front end side. So you need if we take, for example, all the rows there and print a new paragraph for example, for each and every person. Let's take the name from there and hit save. And now check what we have. No qualifying bean, interesting.
Needs to restart.
Usually I don't need to restart, but let's try. Or does this need to be person repository?
Oh, doesn't it need this auto-wire annotation?
I think it doesn't need that because
you have the type defined twice.
What did I copy paste here?
Yeah.
All right. Let's see. But we have it here as well. H2 person not found.
Oh. Should run the init data source now. I think it needs needs to.
This should make it work so that this is happening. There is a wrong package name here.
Okay.
And probably here as well.
Yeah.
In the it was in the classes that I copied from the
imports as well.
Yeah. All right. And now it's not running, so I need Of course, you need one demo effect, but that was not because of my Kotlin skills. That was because of my IntelliJ skills. I didn't realize that IntelliJ doesn't do the refactoring of the package name when I copy paste the full files. I actually did a rehearsal for this session because Kotlin is so new to me, but then I was copy pasting the snippets from a text editor. All right. Now we have at least a query here, but we are not adding that. So we need to add that new paragraph to the screen. There we go. So now we have a ton of rows in the UI, and now let's still fix this because this is usually not the thing that you want to do, because you might have, for example, 1,000 or even tens of thousands or hundreds of thousands people in your database. So you need to use that grid component that I showed you from the website earlier. So let's, instead of putting those there, let's create a new grid. And the type will be person. And no semicolon. And then we will be defining a couple of columns. and we can define these as a add column as a lambda expression. So we will take the parameter person and take whatever we want from that object. So we can take the age and give also the header for the column age. And then let's add another one. Person, and for the name. The ID is not that relevant, so let's leave that out. Name. And now
I believe this is the place where Martin should be waiting for his turn, because like whenever you see repeating variables in Kotlin, this is the place for DSL. So I hope we're gonna see that in a few minutes as well.
We will see actually very nice place when like Martin is using these like field literals in his data binding examples. That will be very cool. So then you will see how it really like bounds to the Kotlin features themselves. So this is now the core Java API, and it looks pretty okay with that as well. But it will get much better, of course, with this kind of Kotlin optimizations. Let's still add the grid to the UI as well. And so now we should get this changed into grid. So now, even if there would be like 100,000 of rows in my Vaadin UI, it wouldn't choke the browser. And it would only take like a couple of kilobytes to send the data from the server to the browser, because it only sends these rows that are visible. So it would be just fine for both the client and a server. And if you scroll, it goes to the server and fetches new rows on the way. So it's kind of a seamless paging without any disturbance for the user or the developer.
Nice. What is immediately impressive when playing with this kind of code is that the UI by default is already styled. So you actually write some Java code that only defines the layout and the components, and then when you open the UI, it's not this solid 90s look, but something stylish and nice by default.
Yeah, and usually they look much more colorful, and for example, in real application, you usually use some kind of a Chrome in your UI. So this is basically just one view of your Vaadin application. Then if you create an example application through our project Kickstarter, then you will get really good looking like main layouts for your application. And then you can just copy paste those examples, and then you can define kind of the parent layout in this root annotation. So if you define a new layout, this view will be wrapped inside there. And typically you have, for example, a class called main layout where you define the full navigation, like the top level navigation for your application and some kind of a header and so on. And yeah, the theming system that we use is actually very handy, even if you don't know any CSS. So we are using a lot of like CSS3 variables, and we have this tooling, which might be a bit better now. Let's see. I don't have actually theme in this application, but if I would have this theme created here, I could use this theme editor to basically pick new color schemes for my application, and this way still kind of avoid touching those lower level web technologies. But of course, at some point, there will be something that is not available in the core component set. We cannot have each and every feature in our components. So at that point, you will of course need to go to the low level APIs. And I could actually show you quickly, for example, with this text field to show some other framework features, actual framework features. So these are features that you will be using if you want to extend the current component set or create completely new components. For example, I have written quite a lot of this kind of extensions for Vaadin. I have taken a ton of this kind of a JavaScript components or widgets, and then just wrap those so that they can be used with the Java API. And then you will be using the so-called element API. So every Vaadin component is basically mapped here in the browser with element. So if you look at the DOM we have here for the text field, we have Vaadin text field. This is a web component, so it contains some special things for styling and so on. So this is hidden by default, but this is the element that we now have a kind of a proxy on the server side. And now we can do anything with here. So we can set attributes for that element, or we can, for example, set the style, set color, green. Let's use my amazing styling. Let's hit save, see what happens. Probably nothing because the color goes to the content. So we need to type something and then we can see the green color. Or then for more advanced use cases, you could go to text field and element and execute JavaScript. So this is what you would be using probably if you want to interact with some JavaScript component that you are wrapping. But usually, yeah, if you start to see this kind of code in your application, then you are doing something wrong. So you should wrap this always into some separate class, and you will be doing those a lot in Vaadin. Most often you are not just using this element API, but you are separating like portions of your application to structure the code and to create, for example, reusable pieces that you might be using in different places in your application. Yeah, I think I have used so much time. I could still show the lazy loading maybe for the grid quickly. So this is maybe something that somebody might have kind of figured out, that if you are getting now the full list of things, this is now kept in the server memory. And if you happen to have an application where you have hundreds of megabytes of data in this table, and if you happen to have a lot of users as well, concurrent users, then you will be wasting quite a lot of memory with your Vaadin applications. So this can be avoided, of course, if you use so-called lazy loading also from the JVM to the database. So we were already lazy loading the data from the JVM server to the browser, but now let's change this data binding to be using a callback. So let's create a Lambda expression here, and you will get a query from the framework, and we can go to the repository, and we will be using this one. So Spring has this thing called pageable, and that's pretty much one-to-one to our query thing. And we have actually a pretty nice helper that converts our query object into Spring's query object. So that's going to be that one. And we will get the query there, and then we will need to give a stream in this return value. So now the connection is like fully lazy loaded. So now if you look, we have like one select query here now in the console. And if we now scroll down a bit, it at some point it goes again to the database and fetches more rows. So now the lazy loading chain is like completed from the client to the server and from the server to the backend. So now it scales easily for like tens of thousands of people.
Nice. I really like how all those components like compose together. Like you just threw in a few things, added a few expressions, and you already have like a working thing in front of you, and that looks nice as well. How do you test that?
We use basically the same tools as everybody else typically uses. So you can use, for example, Playwright, or you can use Selenium, or then you can mock pretty much everything on the Vaadin side as well. And I think I will let Martin give a brief demo, because Martin has actually created a Kotlin library that will help you to test your Vaadin applications as well. So that will be really nice as well. But I could actually show one more thing still before we go for Martin's demo. I mentioned that you are probably doing something wrong if you need to go to this element API. So this is fine, especially when you are creating your own custom components. But before you go to that low level web development and things, then probably you should go first to vaadin.com/directory. So this is a place for Vaadin community members to share all those extensions that they have built for Vaadin, and there is a ton of components. So if if you, for example, need something related to charts, we have, by the way, a commercial chart extension as well available. It's this one. So if you have some money, you can sponsor Vaadin development by buying a license for this one. But there's a ton of these other community built components as well. This chart.js, for example, I have seen this in use by many front-end developers as well, but it's basically a Java API around that thing. Our charts is actually based on a JavaScript framework called HiCharts. That's a commercial, really good-looking chart library made by some Norwegians. And of course, you can search for Kotlin extensions as well. Kotlin. So Karibu DSL, this is Martin's add-on for Vaadin. It's basically wraps mostly like these Vaadin core components and gives you more like Kotlin optimized API.
Nice. So let's bring Martin in for this nice thing. Martin, you
Hey.
probably want to show us how you made it and how it's used, right? I know you have been working on Kotlin DSLs for quite a while. I have seen your DSLs, I mean, like maybe 5 years ago even, and we have some friends of yours coming in and saying hello as well. So greetings from the community. Nice.
Thank you so much. That's really lovely.
So, but I didn't remember the name. I think it had a different name in the beginning, right? So you renamed it.
Actually, there was like two competing libraries. I think at the beginning, there was this Karibu DSL, and there was some other. Was it Vaadin or something like that? And it was I think it was created by
Yes,
Nicola
Nicholas.
Frankel.
Yeah,
Nicola Franco. Yeah. Okay.
exactly.
Yeah,
All right. So
yeah.
show
Nicola
me
is a long
show
time
me the
long
code.
time long time Vaadin user, and he has been tempting me to start using Kotlin for like years and years and years.
Yeah, do that. You won't be disappointed.
Cool
All
stuff.
right, sounds good. So Matti talked a bit about Vaadin being server-side framework compatible with all JVM languages, including Kotlin. And that's true. And Vaadin indeed can be used with Kotlin directly without any need for specialized libraries. But using Kotlin language features makes Vaadin even more pleasant to use. So we are, of course, talking about the Kotlin DSL features, which allows you to employ language features to construct tree structures easily. And Vaadin components, similarly to all other component-oriented frameworks, basically compose components into trees. So that means that we can build Vaadin component tree by using the Kotlin DSL functionality. So there is a library called Karibu DSL. So it's located on GitHub, free for use. So go ahead and use it. So it comes with the ready-made DSL functions for all built-in Vaadin components. So let's take a look how we can use this Karibu DSL to build Vaadin apps easily. So let's build a form editing a bean. So what we are going to do is that we are going to edit a very simple bean. So a person with a first name and a last name, so both of type strings, date of birth, and whether it's registered in a system, and a nationality. So we are going to use text field for the first name and the last name. That's basically the default choice for editing string typed fields. Then we are going to use the date picker for the date of birth. The checkbox obviously for the registered field, and we are going to use combo box for nationality, where we can kind of populate it beforehand with a bunch of nationalities that we can use. And I'll also demo the Java validation annotations that are kind of picked up automatically by Vaadin, and which allows for really easy and nice validation of the values entered by the user. All right, so let's go to the source code, and let's start coding. So since we are going to create a form, so the best way to start is to use a form layout. So we'll just call the form layout function. So this is a DSL function. It just creates a form layout component, which is built by Vaadin. And of course, it inserts it into the parent layout, which in this case is the vertical layout. And in turn, we are going to populate the form layout with additional components. So let's create a text field for the first name and the text field for the last name. And there was the date picker for the date of birth. And the checkbox for the registered. And the last one was combo box, right, for the nationality. And we of course want to populate the combo box with a bunch of options at the beginning. So without the DSL, you would create the combo box object, and then you would have to call these all the functions and set items and other configuration functions on that combo box itself, and that kind of creates a very linear code where it's not kind of obviously clear where the combo box is created, and the structure is not visible at all. So luckily we have the DSL approach. So basically we just can run a configuration closure, and now we can configure the combo box within the closure. So this has the advantage of kind of keeping the configuration of the component with alongside the component definition itself. So it's really easy to find where the component is configured and where it is inserted. So we'll just set some demo nationalities and maybe Swedish. And now let's audit deploy and let's see. So now we can see that we have the initial version of the form ready. It's not bound to anything, so there is no validation going on at the moment because Vaadin doesn't know the connection between the components and the beans yet. So we'll do that in a minute. But first, maybe we want to create a button bar with a save button and a cancel button. So let's do just that. So that would be a horizontal layout. We place the horizontal layout below the form layout with the save button and the cancel button. And maybe we want to make the configure the save button to look a bit different. So we make it primary so that the user knows that this is the primary button which he is supposed to click. And the cancel button is supposed to look a bit like a danger button, so-called danger button, in a way that if the user clicks it, then he knows that he's going to lose all the data that he entered into the form. So we are going to add the Lumo error button theme variant. And now the button should be present in the form. So that looks quite good. Let's maybe make one additional final touch to the form, and let's split the components into two columns. So let's use the power of the form layout. And so that we are going to call responsive steps. And basically you can configure different number of columns for different widths of the screen, so that way you can that the form can always adjust based on the width of the screen and on how much of screen estate you have on your device. But we are going to always force two columns. So now the components should be nicely fit in two columns.
This is a little strange way to write like a string, and then you have like opening brace with a parameter. That's an interesting DSL you have there.
That's I would say the Kotlin dark magic, and I'm not sure this is actually a good idea because this is too dark magicy. It's basically that I'm defining an invoke function or operation on a string itself, and so
within the scope of that lambda, right? Okay. One little thing, the implementation detail, I just cannot skip it all the time you were talking. The distinction between Java API and the DSL approach is that with Java you declare the object and you call add function, right? With the DSL approach, you probably have this add function hidden in each of those DSL functions at the very last line of the function. I just assume, but you
you're
tell
assuming
me.
very right. Yeah, absolutely. That's how it works. So if we go into the text field, well, it kind of calls the init function. Here we are creating the text field component, and we are calling the init function, which performs the addition itself. So the init function is very simple. We just add the component, run the block, the configuration block on it, and that's it. So
that's a very common approach for building the DSLs. I just wanted to to pinpoint on that because like some other people will be watching the stream and maybe they will get the inspiration and like the pointer where to look for the example. Nice.
Sounds good. All right. All right. So now that we have the components created and up and running in the form layout, so let's bind them into the actual bean. So we are going to use a Vaadin mechanism called the binder, which serves for binding fields which has value to properties of a bean. So we are going to do that in configuration blocks. So we are going to bind using binder to the field into person first name, and the same thing for the last name. And basically this is all that's needed to be done. This basically tells that bind this component, so we have this, so bind this component using binder to a property of a person called last name. You can, of course, configure the binding, so you can use converters and all other fancy stuff that Vaadin offers. So I would definitely urge you to read the documentation on the binder because it's a really powerful concept and quite easy to use. And by default, Vaadin basically introduces two classes. One is binder, which just performs the binding itself. And there is a bean validation binder, which acts as a binder as well, but also picks up the Java validation annotation automatically. So this here, actually, the annotation will be picked automatically, and we will have the validation out of the box. So let's finalize the form. Date of birth and registered, and the nationality. Right. And now if we reload, it seems that not much has been changed, but if you notice these tiny dots here, that basically marks the required components. And that's basically coming from the binder. The binder found the not null and the not blank annotations and figured out that the field is required, and thus the field needs to be marked so as well. So, and now the validation should be up and running. So basically, if we type in just one character, then we'll get a validation error originating from the size validation constraint, which says that the minimum length needs to be 3. and this is basically automatically activated for all the fields. The date picker, we need to pick a date in the past, otherwise the validation won't work. And now all that's left is just to verify that the binding actually works. So we call do save, and oh, I forgot to read binder bean. I actually forgot to populate the binder with the bean being edited. So now I did that, and now we call binder is okay. Then we have the bean ready, so we can print it. Person, and we can show the notification. And let's make it let's make it a success notification. So now if we press the save button, well, now nothing happens apart from the validation. But if we fill in some dummy data and we make the validation pass, then we will have the success notification, and we should have the okay, hold on, this one. Yeah, we should have the person being dumped to a console with the appropriate data filled in.
Nice. So we mentioned testing before with Matti. Like, can you tell us about testing?
Sounds good. Yeah, absolutely. So as Matti mentioned, basically, Vaadin serves to create a web application, and the kind of the most common way to test web application is to use a Selenium or Playwright, or basically having an actual browser, clicking through the form, hitting the save button, then asserting that the validation either passed or failed or something like that. But the thing is that Vaadin is actually a server-side framework. And the browser, so everything important happens on the server side, and the browser is just a reflection basically of the server side state. So in a way, we can argue that the browser is not really that important, and what's important is actually on the server side. So with that kind of thought in mind, we can actually skip the whole browser part and just focus on the server side and just test the state of the server side component. And that's exactly what the Karibu testing library does. So we will first discover the views and then set up some kind of a fake environment. So we are going to test Vaadin completely outside of any servlet container. We will basically just create enough mock fake environment for Vaadin to be happy and to work. And then we can actually start calling Vaadin functions to navigate and assert the state of the view. So we can actually kill the server right now because we are going to launch the server in the testing JVM. So let's start the test. So it should pass, and that's not going to tell us much. So let's write an actual test. So we are going to test that when we hit save button, then we want to see that the first name is marked invalid, right? So first name invalid on save. So we are going to, of course, navigate to the main view first, and then we are going to look up the save button. So Karibu testing provides a lot of useful functions to look up components. Button with text save, and we are going to click. And actually, this function does nothing more to it just goes to the current UI and start going through all the components that are actually attached to the UI. Remember, we are still on the server side, so we have full access to the full server state, including all the components, including the database actually. So we can even assert on the state of the database when we push the button. So that comes extremely handy in more complicated applications.
So do I understand it right? That basically with this kind of tests, we throw away the UI and we navigate through the components and assert the state of the components, right? So basically I can check the wiring logic, how the state changes, how you interact with all the server side components and so on. Basically, like, it's almost like integration testing.
Exactly.
But nice.
I mean,
Cool.
it started as a unit testing. Basically, you were supposed to just test the individual components, and if the component would call UI get current, then there would be some kind of a fake environment that it would work. But actually, it's quite easy to go all the way to actually write integration tests even. Of course, there is no browser, so what you can't do is you can't test the CSS and those kinds of things. So there are limits, of course. But there is one huge advantage, and I'm going to demo that one. Right. So anyway, back to the test. So I click the save button, and I'm going to assert that the first name is invalid. So I'm going to look up the text field with label first name, and I'm going to expect that it's invalid. So now we relaunch the test, and it should pass as well. Okay, but well, the correct way to write test is to write a test that fails, and then actually that proves that the whole thing is working. So I'm going to break the test on purpose, and let's run. So since there is no browser, you can't actually see the components, right? But actually, there is a way to see those components. It's just it's not going to be shown in a browser. So now we have the test failing, and we have the assertion error. So there is no visible text field with the label first. And Karibu testing is trying to be helpful here. So this is the component tree, and you can actually see all the components, how exactly they are actually attached in the UI. So we can see that the UI hosts the main view, which hosts the vertical layout, which hosts the form layout, which we defined, and it hosts the text field with the label first name. And that's basically like the aha moment, like, oh yeah, sure, it's a first name, it's not just the first. So this way you can actually see what kind of components you have, and you can see that they are invalid, or and there is even an error message, and basically you can check all sorts of crazy stuff. And you're on the server side, so you can even dump the database if you'd like. And regarding the advantage that I mentioned, so let's fix the test. Regarding the advantage that I mentioned, you can see that the first test, it took like almost a second to run. And that's because the JVM needs a bit of a warm up there. It needs to load all the classes and initialize the Vaadin and stuff and everything. But the follow-up tests then run actually pretty quick. So you can see that the other test run in 19 milliseconds, the smoke one. So maybe it's just this test that runs slowly, so we can prove it that it's actually not the case, and it is the warm-up. It's because of the JVM warm-up by just duplicating the whole test and running the whole scenario again. And now you can see that the first run indeed took still almost a second, but the follow-up runs took, we are counting like in milliseconds. So basically, the whole test suite can run in a couple of seconds, and you can have like hundreds of tests running very quickly. You can now run these UI tests after every commit. You don't have to wait. I remember that there was this customer that had like a really huge, complicated test suite, and it ran for 7 hours. So basically, they were running it during the night, and everybody prayed that it wouldn't fail, because otherwise you would have to debug it and wait for 7 hours. So this way you'll get the feedback immediately, and it's very easy to launch. You can basically just click in your IDE, and the test is just a unit test, so you can run it very quickly.
Okay. All right. I've seen in our private chat that Mati has actually hacked this push example together, and probably we could see that and correct our mistake from the beginning, right? Let's bring Mati in.
Yeah, that was actually pretty stupid mistake because I was creating a new thread in the place where the Spring Boot was or Spring core framework was creating a bean, and that's not illegal. So instead, I'm now doing it so that I have the proper like executor service, and then in a button click listener, I'm scheduling one task that will be repeatedly run, like after 1 second every second. So now if we go to the view and click the button, it will start to hit the browser like every second. So now it's coming with the WebSocket communication from the server, and in a real case scenario, this would be coming from whatever source that you have for your dynamic data. So that's how it works. I could maybe comment about the testing as well. So I think we may kind of miss that, but the Karibu's idea is basically to remove the whole browser side. So you can it's almost like end-to-end tests that you usually build with Selenium or Playwright, but much faster. But in theory, if Vaadin is working correctly, then these tests prove it just as well as a full Selenium test, because it's basically what we are doing at Vaadin. We are testing those components. We are testing them separately, and I can guarantee that our tests, they take hours to complete. but we need to, of course, use Selenium there on the client side, because we want to verify that also those web component implementations, that they also work perfectly.
Nice. Okay. We mentioned that in the beginning, but I think it's worth highlighting again. The example that you've been coding was with Kotlin version 2.0 beta 4, right?
Yeah.
And you used that because of the compilation speed, right? It was much faster than the previous version. Cool, because fun fact, we just released beta 5 today.
Oh, is it faster?
So you have to. I haven't checked that myself. I saw the announcement like 30 minutes before our session. So
yeah,
I
checked the latest version yesterday.
Right. So that I hope it improves, and it's gonna be much faster. So one of the promises that Kotlin version 2 brings is better compilation. Along with that, we're gonna be able to implement better support for Kotlin in the IDE, so it will become even faster there. Although we have spent a lot of time improving it, and the migration path should be smooth as possible, because there are no major breaking language features or anything like that. So thank you for folks for coming. It was very interesting. I think Vaadin is an awesome framework for those who build back office applications, and especially for people like me who don't know anything about front end. I would just like to write my Kotlin or Java code and get nice looking components like by default, without diving into CSS or JavaScript. And obviously Kotlin DSL is like, it's my like one of my favorite features in Kotlin as a whole, and very nice demonstration, Martin. Thank you very much. So yeah, thanks for coming, and I see you next time somewhere around.
Thank you so much for having us.
So
thank you,
folks who are watching the stream. If you have any questions to the folks, please ask in the comments. Don't forget to subscribe to the channel and like the video. It's gonna boost us even more on YouTube. And with that, have a nice Kotlin, everybody.